We're going to take a look at 3 more questions here that I put under mole/stoichiometry. So let's get started. Question 9, we're looking for the percent composition by mass of antimony in stibnite, and percent composition, percent is always the part over the whole thing times 100. Now that is on reference table T, so I can go ahead and find it. Let me just show it to you. I'm going to flip through these other 2 screens for a moment, and percent composition is right here. Okay, my suggestion is anytime you're dealing with a formula, write down the formula and then plug the numbers in so you don't make a mistake. So let's go back. So the part is the mass of the antimony. The whole thing is the gram formula mass for the whole compound. Now it turns out that the gram formula mass is given to you here as 340. So we already know that 340 goes in the denominator, and don't forget about timesing by 100. So all I need is the mass of the antimony. Now be careful, because when you look at the formula, you're not just going to go ahead and fill in just the gram formula mass. It's 121.7, so you would round it to 122. But be careful, it's 122 times 2, because there's a 2 here in the formula. So it's 2 times 122, which of course is 244. So it's 244 divided by 340 times 100. You end up with a percent. If I take it out, the decimal is 71.8%. I'm sure you could fill it in as 72 because it makes no mention of significant figures. But be careful, don't forget, again, to take a look at the number of times the element appears in the formula. Alright, let's check out question 10. We're going to balance the equation for the roasting of this stibnite, and I didn't put the piece here for the equation, so I'm going to go ahead and write that in. So hold on one sec. So I just went to the answer booklet and cut and pasted here the equation that's from the answer booklet right here. Oop, let me just hit this. And what's interesting to me is they give you a hint, because the number 2 is already on the answer booklet for you. So let's start with that and balance with their hint here, because the equation that they gave you in the test booklet didn't have the number 2, but that was given to you, so that's a big hint. So SB, which is antimony, I have 2, but it's 2 in front, so that's 2 times 2, which is 4. So that means I need a 2 here for my antimony. I'm going to go to sulfur next, right, because you always distribute the coefficient, the big number in front, for all of the elements. So I have, not just for antimony, I have to do it for sulfur too. So 2 times 3 is 6 sulfurs. I need 6 sulfurs then on the right. I only have 1, so I'm going to put a 6 here. And now what do I have left? I have to just balance out my oxygens. So I have 2 here, but I need to go ahead and do the math on the right hand side for the total number of oxygens. So I have 2 times 3 here, so I have 6 oxygens plus 6 times 2, which is 12. That's a total of 18. But I have O2, so I got to take 18 divided by 2 to get 9, so the coefficient of 9 goes in front of O2. So I needed 9 O2s, 2 SB2O3s on the right, and 6 SO2s on the right. And now it's balanced. Okay, let's check out question 11. Question 11 asks to determine the mass of NaNO3 produced. So I got to go back and take a look at the whole reading passage here. And we had a question like this already in this mole/stoichiometry for 2005. So I got to pick the information. I got 13.2 grams of my lead 2 nitrate, so that goes here. And I got to add to that 12 grams of NaI, That's on the left. What I start with as far as mass, I end with. On the right, I have 18.4 grams of PbI2 and an undetermined mass for the second product of NaNO3. So 13.2 plus 12 has got to be equal to 18.4 plus X. So I'm going to add up my 13.2 plus 12, subtract 18.4, and you should get an answer of 6.8 grams as the answer. So quite a few questions here with what I'm calling the mole/stoichiometry part of the test. Make sure that you go over them, maybe go over them again, keep practicing questions, and just keep working hard, and good luck.